Bem-vindos to one more episode of the Type Theory for All podcast. As always, this is your host, Pedro Abreu, talking directly from Purdue University in Lafayette, Indiana, of the United States of America. In this episode, we have a man that needs no introduction. Léo de Moura is father of one of the most popular automated theorem provers, Z3. And not satisfied with that huge achievement, he also decides to tackle another extremely hard problem in our field and build his own interactive theorem prover, Lean. In this conversation, we dive into the mind and philosophy of this man with the intent to have a pick on his mind and passion for programming. Now, before we get into this episode, I'd like to remind you guys that we now have a Discord server and we're building a family of PL and Type Theory where we welcome everyone, and I mean it, everyone. All levels of expertise and understanding of our field. And also, if you become a monthly subscriber, you will gain exclusive access to channels where you can send your questions to future guests and even participate live in the recording of each episode. Go to our website, typetheoryforall.com, and become a member of our Discord family today. So without further ado, let's get into this episode. All right, we are live. Welcome back, everyone, to one more episode of the Type Theory for All podcast. This is your host, Pedro Abreu, and I am very, very happy to be here today because this is an interview that I've been looking forward for a long time because it's a fellow Brazilian that's going to be with me here today. But before that, I want to introduce our co-host. Cody Rue is here with us today. Welcome to the show, Cody.
Thanks so much. I feel very lucky to be part of this. I always enjoy being on, and like every time I feel like it's a privilege, so thanks a lot.
So you're still working on Amazon, is that correct?
Yeah, AWS, still AWS, which I think was the case last time we talked.
Yeah, I think we didn't even touch on this last time. I did a really bad job introducing you. So do you want to introduce yourself this time?
Sure, all right. Cody Rue. I love logic and all things logic adjacent. I basically grew up in France, did a PhD in France, came to the US, did a little bit of logic and other things that, we've talked about a couple times on your podcast. And Draper Labs, and then AWS, where I've been for a couple of years at this point.
Awesome. And you also have a podcast now, The Church of Logic.
Oh, yeah, thanks. I'm very not good at promotion, apparently. But yeah, it's just not even close to being the quality of this one, but just me and a few others just talking about things that cross my mind that might be cool, about pure mathematical logic, usually.
Yeah, come on, it's great.
Thanks.
I love that. And today with us, our guest, Léo de Moura. Thank you so much for being on the show, Léo.
You're very welcome. I'm glad you can pronounce my last name correctly.
No. Let me do it completely proper then. It's Léo de Moura. Okay, so Léo, let me ask you, is it okay if I say Léo because I hear everyone saying Léo?
Yes, of
yeah,
course.
It's okay. Awesome. So Léo, I usually, there is this quote that usually says that you can see a tree for their fruits, and we know that your fruits are absolutely amazing. And what I am curious today is to see the roots of this tree. So I'd like to ask you to begin this by telling a little bit of your story. How did you become the lead developer for Z3 and Lean? How did you get passionate about formal methods, programming languages, and things like that?
Yeah, nice. Thank you. Very happy to be here. I was this nerd kid. I loved computer games. I started learning computer science to implement computer games. That was the only thing I care about. But life takes you in crazy directions. At one point, I started learning about static analysis and model checking. And I went to SRI in California to work on static analysis and model checkers. They had this project, the symbolic analysis laboratory. And that's where I started learning about theorem proving. I was always curious. I remember the first time I heard about theorem proving, I was wow, how this works. I couldn't find books about that. I mean, I come from a time there was no Amazon, right? I mean, you couldn't buy online books. Sometimes it was really hard to find books, and I was super curious about that. And in SRI, people were developing a tune improver called PVS. They had a system called ICS that was a collection of decision procedures. And there I met with Shankar, was a big mentor. I had a big friend, Harold Roos, there. He was working on ICS, and I started working with him on trying to combine set solvers and decision procedures. That's how I got into this stuff.
Do you happen to remember what year you came to SRI?
2001. Yeah.
So what projects you were working on SRI? Was that when you were working on SAL?
Yes, was the symbolic analysis laboratory was the first one, but after that I started working on this project to combine set solvers and decision procedures with Harold. Then Harold left, and I started working on my first assembly solver by myself. Before we were trying to combine, I was writing the set solver, Harold was writing the decision procedures, but Harold left. He had to stay in Europe. He's German. He wanted to go back, I mean, family reasons. And I started writing an assembly solver called Yikes at that time. There where I started learning, but was super useful to be there. I mean, people knew, I mean, having someone that can point to you, you should read these papers, right? This is key, right? At the time, internet was becoming popular. People were starting to read papers online. But I think still today, it's a sea of information, right? Having someone to tell you, these are the important papers, it's key, right?
My focus is much lower, but even sometimes there's a paper, right? And it's 20 pages and it's dense. And someone's like, oh, forget about the details, right? The only idea is here. And then, essentially they explain what 4 lines of that paper and, just using words. And it's like, it's so different than just reading a paper and spending a month.
Yes. Yeah, I agree. Having people guiding you helps a lot. I mean, and it was fun. I mean, I had a lot of fun at SRI. I still in touch with many of my colleagues there. And some of them are my colleagues now at Amazon. It's crazy. It's a small world.
It's very small. It is very, very small.
Yeah.
And then from there, how did you start working on Z3?
Yeah, we had Yikes, was SMT solver. Yikes was, I remember in 2006 we had this competition, and the Yikes won all divisions, right? Like a few months before the competition and so on, Thomas Ball came to visit SRI. And we met, and a few months later, he sent me an email saying, do you want to interview? I said, yes. I mean, Bay Area is super expensive, right? I mean, SRI is a non-profit in the Bay Area that is extremely expensive to live there. People that work for big tech companies, they get these stock options, stock awards, and they buy these houses that are impossible to buy if you don't get this kind of support, right? I mean, and I had 3 kids. I felt like, wow, I will never be able to buy a house. I will never be able to pay college for my kids. Yeah, it's a huge opportunity. And it was hard to leave I had so many friends at SRI. It was hard to leave, but it was the right decision. I mean, I tell Tom Ball, I mean, he changed my life. I mean, it was huge change going to Microsoft, right?
I do feel like SRI was the originator of a lot. I feel like, Jean-Christophe used to talk about SRI, and if unless I'm wrong, Rustin Leno was also there for a while. Am I wrong?
No. We met. I met Ruslan while I was at SRI. Ruslan was at Park, right? But we would meet. He would come for meetings. I remember. I have clear memory. The first time I met Ruslan at SRI. I mean, he came for a talk, event at SRI, and we spent time chatting. Yeah.
Yeah, so Jean-Christophe is Jean-Christophe Villatre, and he wrote Y3, which is similar. So a lot of like today's, if you look at the tree, like the genealogical tree of like people that are trying to prove things about programs, a lot of it is rooted right there in SRI.
Yeah, another interesting thing is like Jean-Christophe is the one that started ICS. I didn't intersect with him. I mean, when I joined SRI, he had left, but he was there. He was the one that started the ICS project at SRI.
Cool.
Then he left. I think it was like a postdoc or something like that, and Harold took over the project.
I'm sorry, and Harold, I feel bad, but what's his last name?
Ruiz.
Oh, okay.
It's RUE and the beta, the German beta, but
wow.
they use SS when they write in English.
Okay.
Yeah, I'm still in touch with him.
I think I lost the train of track a little bit. So you said that you started with a competition using Yikes, and then it developed to Z3. I got a little lost. Sorry.
Yes, at SRI, I was working on Yikes, right? It's a SMT solver.
Okay,
it performed well in the competition. I developed it at SRI. I learned a lot developing Yikes.
Mm-hmm.
Then when I went to Microsoft is when I started Z3, right? This is 2006.
So what's the story behind why did you feel like you had to come up with a new SMT solver?
Well, Microsoft had so many projects that needed this kind of technology, right? For example, Spec Sharp was one that Ruslan was the lead. And in Spec Sharp, they were using Simplify, this really old theorem prover developed by Greg Nelson. Greg Nelson, he started this SMT story. He created the main combination, how you combine theories, was Greg Nelson that came up with this stuff in 79. And just to make it crazier, Greg was roommates with Bill Gates.
Oh really?
Wow.
I didn't know that.
Yes, in Harvard. Yes, yeah. It's crazy. When we presented this stuff to Bill Gates, would remember. I mean, when people would present this software verification stuff, they would say, "Oh, my roommate was doing this stuff in Harvard."
That's great.
Crazy guy.
It's different paths,
Yes,
right?
yeah.
Academic.
Yes. Yeah, but Greg had a tremendous impact. I mean, I remember he wrote this long paper with his co-authors, right, about the simplified theorem prover. I think it's more than 100 pages. This is really nice paper. It explains many techniques that people still use today in SMT.
So, not to put too fine a point on it, but Simplify wasn't really cutting it, or it was, it needed a lot of improvements, and Z3 was kind of from scratch.
Yes, it was from scratch. Yeah, we started Z3 from scratch. Especially for Spec Sharp, we really needed support for quantifiers, right? I mean, this is a software verification tool that creates SMT problems that contains lots and lots of quantifiers. This was really important. At the time, we had another project called Sage. It's like a white box fuzzer. The idea is that you create these gigantic formulas representing execution traces, and you want to find the inputs for the program that allows you to execute the trace. Completely different kind of SMT problem. And we had a group developing a tool called PAX that was automated test case generator, right? And all these tools needed something like an SMT solver. Some of them had ad hoc solutions. Some were using simplify. Others implement their own stuff. We had also Slam, that was a symbolic model checker. That's my manager at the time, Tom Ball, created with Sheeran. It was very influential work, this Slam model checker.
And,
I mean, you can find talks by Bill Gates mentioning Slam. So,
Wow.
just to put in perspective how influential this work was.
and Yikes wasn't on the table, I take it.
Well, at the time, open source was not popular as is today, right? SRI was not open. Now SRI releases stuff open source, Microsoft too, but at the time, Yikes was not open source, right? People would release the binary only, and you have to, it's only for non-commercial purpose. And Z3 for many years, like for the 5 first years of Z3, it was closed source, and only the binary for non-commercial applications was available, right? So it was a different time, right?
You know, talking about Bill Gates, it comes to my mind that I'd like to understand a little better how does the MSR relates to Microsoft, and like where does the funding come from? What are the who are the stakeholders? What are the interests there? Is that purely research? What are the outputs that they're looking for, you guys?
Yes, I worked for Microsoft Research for almost 17 years. And I will be honest with you, I cannot answer this question.
You cannot answer because you don't know, or because you're not allowed?
No, I don't really know. Of course I am. I mean, they were always super open, but it depends on who you ask, right? And it changes a lot over the years, right? Uh, uh, when people created Microsoft Research, it was supposed to be like Bell Labs, right? I mean, that was the ideal. Rick Rashid, wow, this guy was amazing, right? He would say, tell us, my job is to hire the best and get out of the way. I mean, what do you want as a researcher? You want this guy to be your boss.
Probably many of the listeners doesn't know what Bell Lab is and how important it was for computer science. Could you give a brief?
Oh, wow. Yeah,
Right?
yeah.
Yeah,
Well,
we're
transistor was
yeah.
invented, right, in the Bell Labs. I mean, so my manager, Tom Ball, came from Bell Labs. Some of my colleagues, like Patricio Defra, came from Bell Labs, right? I mean, but one thing you learn, great things, nothing is forever, right? Bell Labs collapsed. I mean, people, these labs, I mean, is something that people criticize.
Yeah, you could have a whole podcast
they will never
just
last
on Bell
forever.
Labs, right?
Just
like
about
they
Bell
had,
Labs.
Yes, you can
they
have
had a
whole
hallway where
podcast.
it's like 2 or 3 Nobel Prizes was in that hallway, right?
If I'm not mistaken, even Alan Turing has put his feet there in a couple of projects, and also Shannon.
Claude Shannon for sure, yeah.
Alan Turing was there for a brief moment doing some work. If I remember correctly, I might be a little mistaken, but
I don't remember. I do remember that yes, they had this incredible work. They would hire, Erdos had this collaborator he worked a lot with, Paul Graham, I think, and they worked on like graph theory, but the justification was, hey, it's Bell Labs, they're building telephones, they need all this shortest path reachability stuff, at the same time the transistor, and at the same time satellite communications. So at the time, a lot of interesting pure research, a lot of interesting applications, and of course, the not so secret thing was Bell had a monopoly, right? There's only one telecommunications provider, and so they had kind of the breathing room for this. Now, a lot of debate about whether these kinds of monopolies are good or not, but certainly Bell Labs disappeared or started its decline about at the same time the Bell monopoly was kind of dissolved. And not to put too fine a point on it, but there are other companies, not to name any names, that have this huge purview, this huge influence, and they kind of have this breathing room to create these interesting labs full of pure scientists. And give them a little bit of breathing room.
So Leo, you were saying that, yeah, thank you for that explanation, Cody. But you were then saying that then you feel that the idea of MSR is should be kind of a new reborn Bell Lab.
In the beginning was like that, and yeah, was great. I'm super grateful for everything. I mean, they motivated us to do great work. There was pressure, but for me it was great. I mean, I think without pressure, I don't do my best, and having pressure was important. Many opportunities, many amazing colleagues, right? I mean, unbelievable, right? I had so many great colleagues there.
What kind of pressure, mind I ask? Because, like I think of a research place, it feels like go there and do your research. Just go out there and put your time in research, right?
Well, you have to perform, right? I mean, at least this is how I felt, right? I mean, you have to have impact. The impact can be at least in the beginning, can be academic. You can have papers, and you can have impact in the company by having tech transfers, right? You can have impact on society by doing something that's great for society. You had to have impact, right? And people, you see, the environment. You had many famous researchers there. You people raise the bar naturally, right? We had colleagues that would publish like 3 Popple papers in the same year, right?
Wow.
Submit 3
Wow.
papers and get 3 papers accepted. Yeah, right. Yeah.
So then, in that same context, I believe that then it was a similar train of thought that led you towards Lean.
Well, in Z3, I had a lot of fun with Z3. I feel like Z3 had 2 kinds of application. Right. One application is like bug finding, like Sage, where you're trying to find security vulnerabilities. You want to find a bug in the software, or you have test case generation. And this kind of application was really successful in the product teams, right? I remember Patrice Godefroy, he was leading the Sage project. He would share with us messages from the developers, right? Saying, wow, this is magic. How come they found this bug? This tool found the bug automatically. They would say, is this AI? Are you using AI? Is this stuff intelligence? How? But it's just brute force search, right, in the end. And for in this kind of application, you have these huge formulas, right? It's like number crunching or constraint solving is a way to view it. And we had the software verification applications where you had spec sharp, VCC, F sharp, F star, and there are many other software verification tools from outside, from like Y3, SC Java, Daphne. No, Daphne is from Microsoft, sorry. Viper, it was at least at the time. Viper, OpenJML, and so on. But these applications at Microsoft was always the same story, right? Someone would try ambitious projects, like at the time they had the Hyper-V in VCC. Hyper-V, they were trying to verify this hypervisor, right? Properties about the hypervisor. They improved a lot of cool stuff. They created a methodology that was effective. But in the end, they hit these proof stability issues, right? These problems you are in undecidable fragments. You are trying to use a term prover that uses a bunch of heuristics that are fixed, right? It's unrealistic to expect the heuristics will work in every single case, right? So I was frustrated with that. I mean, I remember in this Hyper-V project, many of the proof engineers were in Germany. I visited them and I felt like, okay, I'm going to ask how painful it is to verify this stuff. And one of the engineers told me, look, painful is not the right word. I said, okay, he's going to say something nice about Z3. Then he said, no. Imagine someone puts a knife, 3 knives in your back, and they keep twisting very slowly these knives. And this is how painful it is. I mean, he was explaining his days, where he spent the whole day trying to verify a function. Just for, in the end of the day, someone makes an insignificant change on something he depends on, and he proves break, and he doesn't know why, and where, and he has to go to the beginning. And on the other hand, you could see this was the reality of SMT solvers, right? But when you see interactive systems, I could see people proving really complicated systems, right, with interactive proof assistance. And at the time, we also had this project at Microsoft Research Cambridge, right, with Georges Gontier. I met him, he explained me the project. I was talking also at the time with Cody and Jeremy Avigad, and I started getting excited about interactive theorem provers at the time, and that's what's in the end led to Lean.
Yeah, for context, I think Jeremy had recently, or perhaps it had been a few years, he'd proven the prime number theorem, which, is a real theorem that mathematicians care about.
Yes.
Maybe not worth explaining.
It was before.
Oh, you started talking to him before?
It was in Isabel.
Oh, no, he had proven the theorem.
It was after he finished it.
And as a side note, I always say this, but I'm going to say it quickly, and then it'll be out of the way. Every time I meet someone that works in automated theorem proving, they talk about these... They talk about this proof instability problem. They talk about these heuristics, and they're very frustrated. And then I talk with people like Jeremy, and Jeremy talks about these incredibly tedious proof steps. So in the prime number theorem, right, you're proving something about prime numbers. It's all integers. But of course, you need theorems about integrals. You need theorems about calculus. You need limits. It just comes up. And now you're spending hours and hours proving little, you're reordering pluses. You're turning pluses on ints into pluses on reals. And then you're pushing it up. It's super tedious. It's very finicky. And it drives you crazy, in a very different way. And so Jeremy comes oh, Leo knows all about this powerful automation. He's going to lift this horrible burden of having to really tediously prove these trivial things, by using all this automation cleverness. And so it's a real clash of, opinions where it's automated theorem proving just doesn't scale. It's super unstable. It's full of heuristics. And the people that do interactive theorem proving that this is incredibly tedious. All of this should be automatic. Let's turn to automation. So it was kind of fun. I was just a fly on the wall. I don't feel like I had any huge impact. But at the time to see, Jeremy was really very influential in this interactive theorem proving. And at the time, Leo was Z3 was very popular. It worked for many applications. It's worth, reminding people that this was actually a powerful tool that could prove a lot of things. And so meeting them and seeing how they kind of interacted, with these two different worlds meeting was actually quite fun. Sorry, that's all. That is the only the context I wanted to bring.
Yeah, that's awesome. Is there any particular reason why did you feel, maybe, I don't know, that the theorem provers that already existed were not good enough or something along those lines? Why another one? What was in your mind back then?
Well, I like to implement my own systems, right? That's how I learn. Sometimes I find these questions, for me, it's people create SMT solvers all the time. People create programming languages all the time.
Yeah.
I mean, for me, it's the same thing. I mean, you have to try your own architecture. People say, oh, why don't you try to hack? No, I don't want to live other people's design decisions. I want to have mine. I want to make my own mistakes. Yeah, try again. Lean 4 is completely different from Lean 1, right? I mean, you try, you go and learn more, try again. Yeah, that's how I operate. I don't like this approach like saying, oh, let's get this massive system. Let's try to tweak it to my. No, no, no. It creates so many barriers. In the end, you keep fighting. It's really hard to understand the design. Not even the current authors understand the design anymore. There's a lot of baggage, right? And sometimes the authors want to start from scratch again, but they cannot
Right.
because the users would kill them, right?
We wouldn't know anything about that
true.
with you.
Yes.
Did you ever imagine Lean being this big when you were started?
I'm a man without a plan. I don't have plan. My plan is to have fun.
It does sound like you're a real hacker
yes.
then, that you're just
Yes.
right. And one thing that I did hear a couple of times, I heard some other interviews that you had in other podcasts, which I definitely recommend. Unfortunately, one of them is in Portuguese, so not everyone's going to be able to. But yeah, the fronteiras of software engineering and then building better systems, you were in both of them. And I think you mentioned a couple of times that you had no idea how hard this project were going to be. Could you talk a little bit about that?
Yes. Oh, yes. Because first thing, I was totally ignorant about this dependence type theory. I didn't even know how lights and cock were completely different systems, right? For me, they were these things that at least Isabel Hall calls it tree, right? But
Right,
cock
yeah.
people try to call it tree. I don't know if it really worked, but I knew, okay, these are the three customers. For me, they were all the same. I didn't even know they were completely different systems. Yes.
Okay, it's strange, right? Because in nature, people say, I don't know if this is true, but that things tend to become crabs over time, right? You have all these little mollusks, and they don't really look like crabs, but you look at 20 million years of evolution or whatever, and they all end up kind of looking like crabs. And I feel like with theorem provers, it's kind of the same, right? You start with these two foundational systems. They are different, and I hope we'll get to talk about the details, but they are different. But at the end of the day, when you're proving something in one or the other, they are similar, and definitely the difference is, what makes Lean better than Whole or worse, or Isabel or worse, or Cock, is not the foundations necessarily, or it is, but in very accessory kind of sideways ways. It's mostly about the front end and the user experience, and the libraries, and the your ability to meta program or things like that. And I hope we'll get to talk about that as well. But Lean's is particularly polished,
sure.
I think. And in some ways, this is going back to the previous question, the fact that Lean was this from scratch re-implementation meant you could look at these little front end pain points that have nothing to do with the foundational system, and there you can make different decisions, and hopefully better ones.
What was the biggest challenge for you developing Lean?
Oh, yeah. I didn't realize at the time that these systems are like programming languages, right? I mean, people have opinions about syntax, about little things, and it's overwhelming. I mean, SMT solvers, nobody cares about the syntax of SMT solver, right? The interface is very clean. I mean, you send this file in a cryptic notation and you get yes or no back.
Boom, you're done.
Yes, it's way easier. I mean, for many years I had a love and a hate relationship with the users. For many years. For me, was like my spiritual growth. I think I'm a better human being after
Wow.
this experience. Yes, I'm very introspective person. With Z3, I worked with Nikolai Bjorner. That's also super introspective. Both of us are introspective. We have zero people skills. I think both of us are much better now, but at least when we started Z3, is zero. I mean, and I had to improve a lot my people skills to be able to work on this project. In Z3 also we started closed source, right? When Z3 became open source, it had like 500,000 lines of codes. Nobody, this pile of codes, no, people would say, okay, this stuff is fast. Nobody really care, right? But in Lean is completely different, right? People are looking over your shoulder until, for me to get used to that, right? People commenting on my commits and saying, "Oh, you just have to do this." I hate these words. I have like a freak out when people say you just have to do this, right? Because it's like in politics to
Yeah.
solve climate change, you just have to do this. They have no idea what that's. In the beginning, I tried to argue a lot with people, but yeah, it was hard for me to learn.
Something I'm not sure Leo would say of himself, but I've noticed I haven't worked much with him, but for a week. First of all, I have to say, yeah, I've sort of dismissed the importance of dependent type theory, but it does come up, and his ability to learn type theory was phenomenal, right? He learned it in just so little time. He was just slamming these papers. It was very impressive. But one thing I noticed was, first of all, when he asked me a question, I would sometimes have sort of answer. I had a feeling this was sort of the answer. One thing I noticed is that he would never be satisfied until I'd completely written down like everything down to the rule, the sequent calculus proofs. It was always, I would say Leo is depth first, right? So he will explore a subject and force you to be incredibly precise, and he sort of won't let you go change the subject until he's completely understood the current subject you're on, which I think is great. I'm not sure I'm much more breadth first. I would understand a little bit, and then once I've understood a little bit, I go back and I understand a little bit more, and it takes me years to understand anything completely. But with Leo, he's always completely understand something and then go to the next thing, which is cool because, and this is my second point, usually he completely understands the things he's doing, which is to say when he writes a bit of code, it's usually very, very, very well thought out. And something else that I find extremely courageous is, Lean 1, Lean 2, etc. But even at a smaller scale, features, he would sometimes write these features and spend, 2 days, 4 days. And then he's like, okay, this doesn't work. I'm going to throw it away. I'm going to start over, spend another 4 days. And I don't do that much. I rarely spend a week just writing a ton of code and then just throw that in the garbage. And I find that that's a great thing to do. It's hard, psychologically, but it's great. And so when you have that level of intensity of like trying to figure out how something's going to work and trying a completely different implementation that seems to make sense but end up not working, or it benchmarks slower, and you throw it away, and then somebody online says, hey, why don't you just try this? You're like, hey, I actually I really do the legwork. And so a dismissive comment feels a little bit offensive because it's dismissing a ton of work and a ton of effort. So I just want to contextualize that sentiment, I think.
Maybe that's how,
Yes.
I don't want to, but maybe that's why Linus Torvalds can be really fiery sometimes.
Maybe, you have to be nice, right? That's the minimum amount anybody can require is politeness.
Is there a reason in particular why you chose C++ to begin Lean with?
Oh, great question. So I started implementing Lean. When I started Lean was with Sunho. He's now my colleague at AWS, but 10 years ago he was my intern at Microsoft. And we looked in, we want to have a new, we consider OCaml, PolyML, many versions of ML, but each one has a problem here and there. We considered the Haskell, but they were we were concerned about performance problems. And at the time, by ignorance, we thought Lean would be a library like Z3. You would be able to have it as a backend for Isabelle, Coq, and so on. The same way Z3 can be used as a software library. We also thought Lean would play this role, right? And implementing C and C++ has the advantage that any programming language has a way to call C codes, right? For example, if you're implementing Haskell or Camel, then you want to connect with a program written in Rust, for example. There are all these issues about garbage collector or mismatches between the garbage collectors. It's a pain to integrate. With C, everything can call C codes, right? That was one of the motivations too. It's like this complete unreasonable expectation that we would be able to be a library like Z3 for Coq, Isabelle, Whole Light, and so on. F star.
I have a small anecdote.
This never happens.
At this point, I was working on a front end system, and at the time, Lean was supposed to be kind of this unifying system, but in particular, this was supposed to be a front end to Lean, and I was just developing more slowly. I wasn't, the features weren't keeping up of this hypothetical front end with the Lean backend. So Leo would end up implementing these things and like, pulling ahead. But the other thing was, okay, so here's a point where dependent type theory kind of matters. You can do great things in dependent type theory. In particular, you can define structures like these dependent records where you have data types, but also functions that take in those data types or other data types that depend on these data types. It's very useful because you can define basically APIs as first-class citizens as these record structures. Great. When you try to use dependent type theory, you end up passing in all these parameters, and it's just dozens of parameters. And it's all parameters you can infer with the types of the later arguments, right? So every system that uses dependent type theory has this big inference pass that they use to infer all these parameters. It wasn't obvious at the time, but typing those in is a nightmare. Like, as a user, having to put in this implicit information that all these systems infer is just horrible. It takes hours, it's mindless, it's confusing, it's hard. And so at some point Leo was like, I can't do this. It's too hard to use. I need this kind of front end to help me infer these arguments. And so the system now becomes much more user friendly just because he needs to use his own system.
So one thing that is not entirely clear to me is you say that you had this idea that, you had this vision that Lean would be used as some kind of library. It's a little, I can understand a little better how you can see that for SMT solvers, right? Like you can integrate it for calling other things. So what exactly was you seeing Lean being used for in these libraries? Because, like when I think of a theorem prover, I'm thinking of proving theorems interactively, right?
Yes. Yes, I was expecting we would provide automation like SMT solvers for dependence type theory, higher order logic, and so on. Something that Z3 does not support, right? And I saw many simple problems becoming hard problems when you do the encoding from high order logic, dependent type theory into SMT, right? There's a lot of encoding happening there. I was even giving a talk at the time saying lost in translation, right? The translation puts so much garbage that we sometimes transform an easy problem into a hard one. So I thought, okay, we're going to have this library now that supports a richer logic, and we're also going to have a static framework that allows you to combine basic building blocks of automation, right? And we want it to be super high performance. We want to provide this in the API of this library. Someone would implement the front end, the interactivity, but they would have all these building blocks available. I'm not sure if this can be accomplished, but that was the vision at the time.
Can you just say something? I feel like Z3 does have inside kind of these little building blocks for proofs. Can you just say a word?
Yes, yeah. I was a few 2 years before I stopped working on Z3. I mean, Grant Passmore, another great friend of mine, and I started working on adding a static framework to Z3. It has a cool feature, right? Static frameworks in the LCF family, they have this idea of you create sub-goals, and if you have, it has a backward function that's giving the proofs for each sub-goal, it builds a proof for the original goal, right? And Z3 had that and a function that giving a model from one of the sub-goals, it builds a model for the original problem, right? So you have proofs and counterexamples, right? Models for representing counterexamples. You had both in Z3. And this was cool. I mean, we had some really cool stuff in Z3 using this architecture. And I had a lot of fun with Grant. I mean, on writing this paper, working on this stuff with him.
And now you moved on to writing Lean in Lean itself. How was this transition?
Yes. Yeah, in Lean 3, we add the capability of extending Lean using Lean itself. Was the first Lean 3 is the first one that has a decent static framework. And the cool thing is that you can write your own statics using Lean. And you mean, oh, why did you do that? We did it because we felt it was cool to do that. I mean, but it was very popular with the users, right? Mathlib, I think, has like more than 40,000 lines of Lean code for this code is Lean extensions, right? Mathlib has more than 1 million lines of Lean. But 50,000, 40 something between 40 and 50,000 is just Lean extensions, right? And this was great. I mean, because people would complain about, oh, we don't have this feature. Say, oh, you can implement yourself the feature using Lean. I mean, and that's one lesson I learned is with both Z3 and Lean, adding convenience is the most important thing you can do in any system. Users love convenience. People tell me, oh, yeah, you can write extensions. If you use your camel, you build a shared object, this shared object truly. Nobody will do it. I mean, maybe one person will do it, but it's so painful. If you make things convenient to use, people will use it. I have a funny story about Z3. Sorry, it's about that. Gio Hot is this famous guy. I mean, he unlocked the iPhone. At one point, he was visiting Microsoft, and he told his host he wanted to meet me because he loved Z3. And then he comes and says, wow, man! He has this really intense style, right? He's saying, man, Z3 is awesome! It's the first usable SMT solver. I thought he was going to start praising the performance, right? He was going to say how great the algorithms were. No. It's the Python bindings, right? I mean, there's 3 Python bindings for him. It made it so easy to use SMT. That is what mattered to him, right? That's why he was using Z3. That's why he found it useful. Had nothing to do with my papers, with the performance, all the time. The Python bindings were the most important thing. And in the end, what he was telling me is convenience is important, right? And the same thing for Lean, writing Lean extensions in Lean itself, and Lean creating the background, the shared object for you, linking it, doing all the magic. This is important, right? It made a big difference.
I love that story, by the way. I think I'd heard it before, but it's really stuck with me.
Yes. Yes. And writing Lean was our next step. We said, okay, this stuff is so popular. Let's do everything in Lean, right? And then I have these people that are heroes, right? I mean, it's like two people that were super heroic efforts, right? Helping me with Lean. The first one was Sun Ho, right? It's insane, right? And the second one was Sebastian Ulrich, right? I mean, he was starting his PhD, right? And we say, we are going to build Lean in Lean. Wow, I mean, he's saying, I'm going to do my thesis on this stuff, but what happens if it doesn't work, right? How is he going to complete the PhD, right? I mean, and he says, let's do it. I mean, let's do it. And it's a lot of pain. I mean, he went with me all the way, right? I mean, it's I can't put in words how much I appreciate his help. It's unbelievable.
So he was kind of like an intern in MSR. Like, how did that contribution happen, actually?
Yeah, he started. He was a master's student when I met him. He wrote his master's thesis using Lean for Rust, very fine Rust code using Lean. He was using Lean 2 at the time, and I think his first PR to Lean is from 2015. I think around this time. I mean, he started contributing, improving the printer in Lean 2. Then he helped. We wrote this paper about writing Lean tactics in Lean. We wrote together with Jared and Gabriel Abner. The four of us work on this stuff. And he became a contributor. And then when we were going to start Lean, it was like a huge project. And Sebastian said, yeah, let's do it. I mean, yeah, it was great. I mean, it was like this, you have this huge mountain you have to climb, I mean, but you're not alone.
So he's been working in his university, not directly in MSR. He was not like being paid by MSR.
No, yeah, he did one internship.
I see.
He was going to come for seconds, but COVID hit, and the internship had to be canceled. But we had an intense collaboration the whole
That's
PhD.
amazing.
I mean, yeah, we talk several times per week, and yeah, we still talk all the time. I mean, yes.
I just want to emphasize this notion of convenience and the notion of being able to write tactics in the language itself. I really suffered from that. Like in Coq, it used to be when I started using Coq in like 2006 or something. There was basically no tactical language. It was you had to drop into OCaml, and people were like, yeah, you drop into OCaml. You just have to compile. You have to recompile against this thing. That's already like a showstopper, right? If you have to compile anything ever to use it, then you've lost maybe 90% of your users. So Coq is like, okay, well, let's come up with a language. They came up with LTAC, and LTAC makes sense, and it has a lot of things. Here's something about LTAC. You don't know what the types of the operators are. You don't know what the output types are. You get errors. They're terrible errors. It's gotten much better over the years. But at the time when I started LTAC, the errors were completely opaque. This is a non-deterministic language. It's very hard. It's very confusing. And then you go back and you try and stare at existing LTAC code. You can't read. It's a different language. It's a different programming language. So the beauty here kind of is you understand Lean. It takes time, right? It takes work. It's like everything. But once you understood this, you're already halfway there. You can just print types. You can just look at code. It's the same kind of code you've been writing for months. And so, yeah, there really is something to saying, hey, this language we're going to do the metaprogramming in the same language And of course, this is the Lisp philosophy kind of like being your own meta language.
No, I was going to mention that's a big surprise I had. That's I never. Of course, I expected people would write their own extensions, but I would never expect mathematicians would do it too, right? I mean, you have mathematicians like Patrick Massot. He wrote really complicated extensions, right? I never expected people would spend time learning this.
Okay.
This kind of stuff.
I talk too much at these things. We invite these people that have interesting things to say, and I always want to talk over them, which is a terrible habit. Two anecdotes. One, it wasn't obvious to me at the time that you could do this, right? Of course, Lisp, there's an eval function. You can pass in any piece of syntax and it turns it into Lisp and, maybe that part. But with a theorem prover, like, you can't be as loosey-goosey, right? Everything has to be consistent. So you can't just add, an eval function that does whatever it wants, right? So you have to be a little bit careful. There's some cleverness here. The other thing I wanted to mention is it always struck me like, any feature you add that's going to extend the syntax of a programming language is scary to me, inherently scary. People were terrified of these syntax extensions in Coq, and for somewhat good reason, because your syntax errors are hard to read. They're a little bit confusing. Sometimes you don't understand why something doesn't parse. Sometimes you don't understand why it parsed one way and not the other way, right? Parsers are hard. And if you give the users the power to write parsers, it's potentially hard. I remember bringing this up. Like, I was a little bit scared of this feature. And I do remember Leo saying, oh, no, this is trivial. I'm just going to implement this parser. It's a really simple parser. I got it from this, 1972 paper. And, I look at the paper, and it's just inscrutable, magical algorithm. And I was pretty impressed. That the syntax extension feature, it's a very useful and a very crucial feature in a theorem prover, and special care was paid to it.
No, I definitely agree, actually, because there are some cool meta programming things that I wanted to do in Coq, but in order to do it properly, you would have to learn how to make a plugin, and you have to, hack kernel stuff and get around, and that's, I have to get out of my way to learn other technology and compile other stuff, and I never mustered the courage. It's exactly what Leo is describing. It's in my to-do list. I will learn to do Coq plugin someday because I think it's cool. But if I could write it down in Coq itself, which you can nowadays for some part with MetaCoq and stuff, but it's not the same, right? But that is actually really convenient, and I really appreciate that. But one thing that comes to my mind is in this idea that Code is saying that you can extend your language as much as you want. Like, how do you deal with soundness of your language, allowing?
You cannot extend the kernel, right? The kernel in Lean is fixed, right? You can add your own elaboration functions, your syntax, your printer, but the kernel you cannot extend, right?
What is in the kernel?
Oh, the kernel will have the type checker, right? We have the expressions, the declarations, all the type checking is done in the kernel, right? And we have external, another thing we like to have in Lean is external type checkers, right? And the community has implemented many. They are being ported to Lean 4 now. And it's something that we really care about. I mean, I think having external type checkers raises so much the confidence. And some of the external type checkers, they have their own printer. just, I mean, sometimes people have this concern, oh, you prove something, but people may have played with Unicode to trick you what you actually, the
Yeah.
statement. Okay, no, we export, you can print yourself. And there are users that care, right? There is this cryptographer, I forgot his last name, embarrassing, it's
Kronig.
Daniel, I
Not
forgot his
Kronig.
last name.
Yes, Kronig. Great.
Yes, yeah. And he cares about that. I mean, for I mean, if you're proving high stakes stuff, right? You really want to be sure that you prove what you think you have proven, right? And having this kind of capability is important.
So yeah, so I think the answer to your original question was in Leo's first answer, which is all this metaprogramming capability essentially is a very, very, very fancy way of desugaring these propositions and proofs. And once it's desugared, that thing is not extensible. The desugared, syntax of theorems and proofs is fixed. And the checker for those things is A, simple, and B, auditable.
But people asked me once if they could use Lean. Oh, Lean is extensible. Let's implement Cubicle using Lean. I said, no, sorry. The kernel is not extensible.
Well, but now it actually comes up to another issue that I'm not sure how it's completely handled nowadays. But the thing about constructivism, and I've seen heated discussions about how Lean is not entirely constructivist and things like that. What is the state of the art, and what are your thoughts there?
Okay, great. The first thing, I love constructivism, right? I think I find exciting, but for practical applications, right? I care what the users care, right? I mean, at least the Lean users care. And now you have in Lean people that care about software verification and people that care about math, right? And the mathematicians don't care. At least the mathematicians that are working using with Lean, right? They don't care about constructivism, right? I mean, they don't see what's the deal, why it is important. They simply don't care. And this is another fact. This is a fact. Implementing automation for constructive type theory or constructive whatever is way harder than for classical. For classical, things are uniform, are much easier to automate. When we started Lean, we were supporting at one point constructivism, homotope type theory, but we started dropping. I mean, it's a lot of work to support these different flavors, especially if you care about providing automation. Sometimes people tell me, oh, if you are constructive, you're proving a more general result. Then I tell them, look, suppose that someone asks you to prove the TLS protocol, right? Nobody cares if it's constructive or not. Nobody cares. The proof is constructive. The people that care are the crypto algorithm. Oh, I proved this complicated crypto algorithm using constructive principles. I'm saying nobody's saying 99% of the world doesn't care, right? It's super hard already to prove these things using everything that you have available. And it feels like I had many discussions with many different people, and many told me, wow, you are self-inflicting pain on you, right? On yourself, right? Making something that's already super hard even harder. I use this example of the Hyper-V, right? These guys were suffering there. They were using classical reasoning to do all the proofs. Imagine I arrived there, guys, now we have to be constructive. They say, oh, it's going to be easier. No, it's going to be even harder, but it's going to be more general. It is hard. I mean, I'm a pragmatist in the end. I mean, I want to deliver results, right? And I respect people that I view the beauty, right? I had a lot of fun playing with constructivism, but I don't waste cycles anymore, right? If the automation is easier to implement using classical principles, I use everything. I don't care, right? It's funny you ask this question because people are discussing that this week. Some Lean users were asking for support for constructive. Oh, let's avoid these classical axioms here. And my stance is show me a high profile project that will benefit from this feature, right? If you can show me something that will be impactful, for example, they had in Lean these liquid tensor experiments, right? It was super impactful project. Show me a project that will be impactful like LTE that cannot move forward because Lean is using classical reasoning all over the place. If someone can show me that, okay, let's talk. Otherwise, yeah, it doesn't make sense to me to support it.
I like that. Honestly, having different theorem provers for different things, I think it's a very good idea. And like having this theorem prover that is classic by design and using all the things that you can do with classical logic, I think it's good. It's good overall.
You have to pick your battles, right? I do remember, Leo, we talked about foundations quite a bit, which I love. I love foundations. I love logic. At some point, when you're pragmatic, right, I think for the foundations, Lean was very careful to not try to be clever, right? We thought about all these different type theories. We thought about, observational type theory. And at each point, and I think this was the right call, Leo was like, okay, if I can't look at something where they explain every little detail of how the implementation is supposed to work, then I consider this to be experimental and I'm not going to do it because then you end up just doing that, right? Like observational type theory. You want to build a theorem prover for that? You're going to have to solve a ton of theoretic problems and you're never going to get to this library design packages. We haven't talked about packages yet. The code extraction, you end up getting stuck right at the beginning, right? So you kind of have to pick that battle. And at the time, the calculus construction was relatively well understood. The classical axioms are quite well understood. If you're doing math classically, we know the proofs. So that's it's easy to say, hey, I don't want to spend all of my time thinking about this. You pick all the classical, frameworks.
Yes. Yeah. And it's fun sometimes that there are people that I find online saying, oh, something really bad is going to happen, right, in Lean because of this classical axioms.
Nah.
Yes. Yeah.
There was this non-termination thing that was a little surprising at the time. I don't think it changed anything, right? It didn't make Lean, scarier in terms of consistency or harder to use, but
No,
it was a surprise.
Yes. Yeah. Yes. And to be honest, it doesn't happen. I mean, this affects the accessibility predicates that we use for well-founded recursion. Something that's in Lean, the user never sees. I mean, we use these predicates only when we are justifying. The automation in Lean is justifying why a function terminates. Like the user, we try really hard to hide this stuff from the user to make sure he never sees this stuff. In practice, has no impact. And people say, oh, something horrible will happen. Yeah, MathLib has more than 1 million lines. I mean, look the amount of math that has been formalized there. This is not an issue, right?
Is there a how can I blanked a little bit, but is there an argument for correctness of Lean? How do you usually do that? Go about that?
Yeah, many mathematicians ask this question. Mario Carneiro, he had a master's thesis about where he gave the semantics in set theory. But of course, he covered what we had in Lean 3. For Lean 4, Sebastian worked on some extensions we had. Yeah, but Meyer's work is basically the main reference people use when a mathematician comes to the community. Some of them will ask, "Oh, I want to understand what's behind. What's this type theory all about?" And people usually reference Meyer's dissertation.
When a mathematician comes and asks, like, why can I trust this, right? Because I can trust my pen and paper, I can see what's happening, but why can I trust that this system is doing what it's supposed to be doing, right?
Yes, the meta theory we show the set theory formalization. It's done in pen and paper, right? About the implementation, we say, look, there's the kernel, but even if it's possible the kernel may have bugs, right? Of course. But then we tell, look, you can implement your own external type checker. There are all these external type checkers people have implemented. People have implemented in Rust, Scala, Haskell, and so on, right? And you can use them to check your developments, right? Basically, that's the answer we give when people ask this question.
It's a pretty solid answer, I would say. It's pretty strong. I think if I wanna, I think there were some work to do a type checker, like other type checkers for Coq, or at least like a fragment of Coq, and it's really hard. It's really hard to like do my own type checker for Coq, for example. So that's really good. That's really cool.
Yeah,
you're gonna add
that's
something.
That's a good question. I was going to ask another question, which is, there are some subtle points in Coq for the type checker, and I think the main subtle points are the module system, which I'm not overly fond of, but even disregarding the module system, I think the two main subtleties of the Coq type checker are the guard checking, the termination checking, and the universes. Right, you have this kind of tower of type universes, and you sort of want to say that tower is non-cyclic in some sense. I'm curious about how Lean addresses those two stories. Does it have some ideas there that make it a little bit easier to handle than in the Coq case?
You know the answer.
Maybe I do.
Yes, one thing in Lean, we don't have a termination checker in the kernel. When you declare inductive data type, we create a recursor in the kernel, right? And we compile everything to these recursors, right? So there's no termination checking going on in the Lean kernel. And for the universes, we have parametric polymorphism, but we don't have cumulativity like Coq, right? And I have to say, sometimes people miss cumulativity, right? It gets in the way sometimes, not having cumulativity, right? One example is if you have an abstract bind, like the monad binds operator, right? You have two actions we are trying to bind together, right? Using this operator. In Lean, they are going to be in the same universe, right? The types from these two operations will be in the same universe. With cumulativity, you can get away. They can be in different universes, right? There is a price to pay, right? I mean, you're going to have to put lifts. I mean, the solution for this case, you have to put lifts. You get away in practice because usually when you write monadic code, you're in type 1 anyway. But sometimes it bites you back if you're trying to write generic
But
code.
Do you feel, if you had to do it again, and you kind of did, you'd make that same choice?
Yes, I would be for pragmatical reasons, right? It's going to be such a pain to support. cumulativity and parametric polymorphism there. Yeah, I would make the same choice. Unless there is something that's completely blocked that we want to do, there's no way around it, yes, then let's do it.
What were some things in particular that throughout the development, from Lean 1 to Lean 2 to Lean 3, that you looked at it and you're like, nope, we're going to have to throw this one away and we have to implement this part? What were the key factors for moving from one language to the other?
Okay. From Lean 1, I was basically learning type theory, right? And I want to be as foundational as whole light, right? And so in whole light, Isabel, Hall,
wow.
Reductive data types are not parts of the kernel, right? They're constructed from first principles. In Lean 1 was like that. But then for dependent type, it's a pain, right? So you need to have iota reduction in your kernel. Otherwise, the amount of pain is unbearable to use the system, right? That was the main lesson from Lean 1. You really want to have let expressions. I mean, in whole lights, in Isabel Hall, let is just syntax sugar for a lambda with applied lambda, right? Independent bacteria, you learn this is not enough. And the second
I learned this
was
from
like,
Leo.
you really want iota reduction. Yes, yeah. You really want iota reduction in the kernel. That was the main lesson for Lean 1. In Lean 2, the main lesson was, actually, Adam Shipala made this comment to me. He told me, you need a real tactic framework. This is really, you can get... That was a lesson from Lean 2, right? So we need a real tactic framework. In Lean 4, it's like, wow, Lean is getting traction, it's popular, let's do everything Lean. We're going to be more productive too, right? It's easier for us to take contributions. I mean, C and C++, if you have experience, you know the subset that is safe. But if you start taking external contributions, sometimes, even if you're experienced C++ developer, you don't know the whole language. You know a subset. And people contribute with stuff that's out of your subset, you know, and nasty bugs happen, right? Sometimes it's really hard to spot. It's like tiny mistakes, right? And so getting contributions was a problem to be C++ at that time. The code was getting messy with I also didn't know how to manage. Another lesson from Lean 3, learn to manage open source projects, right? In Lean 3, I started having contributors sending codes, and I had a hard time saying no. I started merging everything because I had a hard time saying no. I felt bad. And learning to say no, learning to say no, you have to do better. You have to comment your code. Yeah, I mean, learning how to manage open source projects was part of the Lean 3 lesson.
That is awesome. I really appreciate how you say that. Like comparing building Lean as this spiritual journey that you're learning. How to do with people and things like that. It really got me by surprise. Like I ask what was the biggest takeaway from developing Lean, and like dealing with people. I wasn't expecting that.
They are more complicated systems, right, than even C++, right? Still just kind of contained, but people...
Yeah, people are harder than technology.
Is there anything in particular, do you think would you compare developing an SMT solver to implementing a dependent type language? Is there anything that struck you particularly as surprising?
I was happy and I didn't know. Yes, so much easier. I feel like, it's like SMT solver is a black box. Nobody cares what's inside of the black box, right? They care if the answer is correct, right? It's easier to make SMT solver users happy, right? I have tremendous respect for the Coq developers, for the Isabel developers, Agda, Hollight, and so on. I mean, they are heroes. I mean, wow, it's hard to make your users happy.
And that's not even
It's hard to
right.
make people happy.
It's not even like Python, right? Like Python,
Yes.
the number of users must be like at least, 2 orders of magnitude more than Lean. I love Lean, but
Oh yeah, it's a good point. Yes, good point. Good point. I mean, for example, people complain about Linus Torvalds' behavior, right? Man, I understand him. I mean, imagine Linux is gigantic. Imagine the amounts of pressure people put on
Yeah.
it.
Yeah.
I would be sending F bombs all over the place if I was in this position too.
Uh, glad you didn't though.
yeah,
Yes,
Good.
yes.
You're so nice, Leo. I would be very surprised if I see something like that. But yeah. It's tricky. I cannot begin imagining. It's too much. It's too much pressure. But in other, yeah, changing subjects a little bit. In other interviews you mentioned how you think dependently type how dependent types are very beautiful. I was wondering what is so beautiful for you? Like what is this? Maybe I'm reflecting, or maybe your mind has changed. But back then, I could feel this sense of
No,
awe when you're learning dependent type theory. Where does that come from for you?
yeah, I like to start reading from the original sources, right? One thing, I mean, it may sound silly now, right? But I remember this book from Martin Love. He starts introducing, oh, this is products, this is the sum, this is that, this is that. In the end, he says, oh, these are all instances of a generic principle in the induction principle. Then, in my mind, he connected something that I never noticed. That's all these natural deduction rules, inductive data types, that in my point of view are completely different things or manifestations of the same thing. I said, I mean, I was blown away. I was blown away. I said, wow, I never realized that. I mean, it's beautiful. It's beautiful. I remember Cody and I talk about this stuff at one point, saying, "Look, the substitution, equality. Oh, this is an induction principle for equalities." And yes, it's beautiful. Yes, this is beautiful. Another example was when Georges Gontier was showing his developments. Right, he was working on this big projects, right? The Fay-Thompson theorem formalization. And he shows, I mean, oh, look, ring is a data structure in Coq. Look, I have the fields, I have the properties that a ring must satisfy. This is just a data structure. There's no, is uniform. You don't keep adding new concepts like, oh, you have a module, you have a template. No. This is just a structure as any other structure in the system. And this structure is an instance of an inductive data type. I mean, this is beautiful. It's like the minimality is beautiful, right? The unification is beautiful. Yeah, I remember I had a blast. 2013, I was learning these things in 2013. I had a blast. It was 2013, 14, were intense. I had a blast.
yeah. There's something very
Wow,
beautiful about
that
this.
is beautiful. And then another thing that also, well, first of all, let me take a minute to internalize that, because I really like that answer. I could like really feel the excitement and the awe, the sense of awe, which is why in a sense I feel all of us are doing this. Like this is, I feel that in the end of the day, this is the reason why we are all here. that moves us, that makes me, for example, to come to the US to get a PhD, right? It was the sense of there's something fundamental here. There's something deeper. There's something, that's hitting a core of some sense, right? And it's beautiful. It's beautiful. Now, another thing that really, talking about the other interviews that you gave, another thing that really struck me as a very original argument for ITPs that I have never heard before, and I love it. I love it because it's also very dear to my heart. You mentioned that interactive theorem provers can make math a lot more inclusive. Can you tell us more about that?
Yeah, I think this is a realization of the whole Lean community, right? I'm just an observer there, right? I see all these people working together, and it blew me away. I mean, I remember when they said, we're going to build this library for mathematics. At the beginning, there was swim meeting I had to manage in the beginning. There was swim meeting to the Lean repo, but was overwhelmed. I said, guys, I can do that. It's too much, right? To manage all the PRs. Then the MathLib became a separate project. The community was managing. And I felt like, wow, this is not going to work. To me, to build a library, a mathematical library, a formal one, it's like software, right? And in my mind was clear, you need discipline, right? I like to work. For me, the most important quality in a co-worker is discipline. Like Suho, super disciplined. Sebastian Ulrich, super disciplined, right? You need to have discipline, right? And I said, wow, mathematicians, are they going to do that? It's not fun sometimes. Developing software sucks. Sometimes it's painful.
Yeah.
Sometimes you have to go there, clean up stuff, refactor. I said, a mathematician doing a refactoring, they're going to hate this stuff. I mean, this is work that people feel like it's boring, right? I felt they are going to fail. I mean, they don't know what they are doing. They're going to fail. I felt okay. I felt sorry for them. I remember Kevin Buzzer telling me, saying, man, you're going to fail. I mean, this is like software. You need discipline. And they succeed, right? It's like, my lesson for me is the power of the community, right? The power in numbers, right? And the fact that formal mathematics allow people that don't know each other to collaborate because there is a checker in the background checking what they are doing, right? I feel like this is powerful. The idea also, like many people in the community, like this idea that you can. How many times you read a math paper that you say, "Oh, we got stuck. I don't know that. I can make progress." Right? I don't know this stuff they are saying that's obvious for me is impenetrable. They're saying it's an obvious step, but for me it's not. Right? And formal mathematics allows you to keep digging. And there are many people that do that. I mean, there are people that can understand now what a perfectoid space is because there are these guys in the Lean community, Kevin Buzzard, Patrick Massoy, Johan Komelin, that formalizes these concepts in Lean, right? I think this is magical. It doesn't connect to everybody. I remember I had a colleague at Microsoft. I would say, "Oh, we're going to democratize mathematics." He says, "No. Come on. Nerds like you are going to be able to learn mathematics without a professor." But math education is way more complicated than that. But yes, okay, it's a valid argument. But I can see a lot of people can learn, right? I mean, without just playing with the computer, interacting with people they don't know. Another example that blew me away was the liquid tensor, right? I remember Johan, Kevin telling, we're going to do this project, right? It's going to take years. I said, yeah, these guys are going to fail, right? I mean, it's a result from Fields medalists. No way they will be able to do it. But Kevin said, no, we're going to try. People are going to try. If it takes 3 years, who cares? We're going to keep doing it. And in a few months, they did. They proved the main results that Peter shows they cared, right? I mean, I couldn't believe. I mean, I was blown away. It's the power of numbers, people getting together. They're always heroes, right? Showing up from everywhere. For example, we had this link port from link 3 to link 4, right? With
Yeah.
these
Yeah.
dramatic changes in the language, right? We felt like now we know we are now PL people. We felt, at least Sebastian and I felt, okay, now we can claim we are programming language researchers, right? Let's do a proper language. And so the language is not backwards compatible, right? There are many tiny differences. And they had 1 million lines. When we started in 4, it was only 40, right? It was not an issue. It felt like, well, in the worst case, we translate by hand, right? But 1 million is a big deal, right? How do you translate 1 million lines? How is this even possible, right? Everybody telling it's impossible, you're going to fail, Lean is going to be like Python 3, Python 2, nobody will. And the community did it, right? It blew me away. I mean, people from nowhere showed up. The top person, they keep statistics, the person that translates the most code, nobody knows. This guy, I think, is in Singapore. Nobody knows this guy.
Wow.
I mean,
Wow. Wow.
he showed up and translated a lot of stuff.
There's a fascinating confluence here, right? Because with mathematics, right? With handwritten mathematics, people tend to, there's a lot of implicit things that people need to understand, right? And so being physically close together is important. Being, in a college and being able to talk is important. But with programming, with normal programming, there's a different problem. You're all sharing a computer, and obviously nobody's computer is the same, but it's the same system, right? If you're running Python, the same version is consistent. But if a bunch of people contribute code, that code can be buggy and in ways that's really hard. For humans, it's really hard to review code, and you have to. With what's kind of beautiful here is, first of all, in mathematics, the definitions are mostly agreed on, and emphasis on the mostly, but there is consensus on the definitions. And 2, if a user who's not part of a group writes a proof, and that proof type checks in Lean, that's done. You don't even need to look at the proof. You might want to, you might need to maintain it, but a first order approximation, you don't even need to look at that proof. And I think that's the point Leo was making. But it's really a combination of, here's how math works, and here's how computers work. And if you just take computers, programming, it's hard to be so intercommunitary. And if you just take math on paper, it's also hard for different reasons. But the two together, there's really something that does happen.
And you don't really, like, we wish it wasn't really like this, but in a sense there is some kind of trust in the person who is coming up with a proof. So for example, Kevin, was telling how Kevin Buzzard, by the way, was telling how Chose was complaining to him that nobody actually checked his proof. That's why he wanted the TensorFlow project, right? And so people just, because he's the field medalist, people just trust that it's correct, right? Now, one thing that I think is fascinating is to imagine how many Ramanujans didn't get their chance because they're not part of the community, because we don't know what they're doing, because they don't have the formal training, right? So Ramanujan, in that sense, he was very lucky to have one mathematician to back him up. And if our dream here is true, we can make it true, right? This is not going to be such a big issue anymore. We have ITPs in our hands that we speak by their own. And anybody can learn this anywhere. Doesn't matter your background, doesn't matter where you are, doesn't matter your university, doesn't matter how much money you have the opportunity. And that's beautiful. So thank you, Leo, for working on this. Thank you for making this, like another step towards that. And you also mentioned this quote from Foundations, which I thought was amazing. and I'm gonna try to retell it right now. I'll try. You can stop me if I'm getting anything wrong, but there is this part of foundations where I don't know how many years in the future, many years in the future, thousands of years in the future, they still think this is gonna be a problem because there is this girl that solves a very hard problem, and they have to call up this amazing mathematician to check out her work because nobody knows who this girl is. Nobody trusts what is going on. Nobody believes what is going on, right? So in Foundations, Asimov thought that this was still going to be a problem thousands of years from now. And maybe that's not going to be the case, right?
Yes.
And I love that.
Yes. Yeah. I had to become a little bit of a salesman to fund the project, and I'm always looking for ways to communicate. And I was watching these episodes. I said, "Wow, I can use that."
That's great.
That was a great one. Well, yeah, you did a great job. Well, so I think we're starting to run towards the end here. I'm starting to run a little short on questions. One thing that I still wanted to touch on is I'm curious what is behind your transition between MSR and AWS. And the reason why I ask this is I'm curious how this might impact Lean's development. And
Yeah, it's a great question. I mean, as I said, I'm super grateful for everything Microsoft's research offers over the years, but nothing's forever, right? One big change for me was AI, right? Now there's a huge focus on AI, right? And the economic downturn and the AI had huge impacts, right? I mean, at one point, the future was looking bright. I felt like we would be able to hire Sebastian Ulrich and others at MSR, right? And have a group working on Lean. But the reality was that with the economic downturn and the AI being this tsunami, right? I mean, it's impossible to ignore, right? It's going to have huge impact. And I understand the leadership wanting to focus on AI, right? But at one point, I felt about, okay, I'm going to start working on AI and math, but it didn't go well. I mean, I felt like Lean is important independently of AI, right? It felt like it's too much to do this kind of career changing the direction, right, to AI and focusing on that. And at AWS, I mean, there's a huge automated reasoning group there. It felt like was a better home, right, for what I care about. So I'm really an automated reasoning person, right? Even with the success of Z3 and Lean, there's no automated reasoning category at Microsoft Research. There is theory, programming languages, computer graphics, AI. There's a bunch of categories that you can select as your area of expertise, but automated reasoning is not one of them, right? And at Amazon is the opposite, right? There are more or less 200 people that are working automated reasoning. That was one of the motivations. And at the same time, when leaving Microsoft, Sebastian and I were also creating these nonprofits with convergent research, right? Now we have these nonprofits that will ensure that Lean keeps going. We have people maintaining. There are so many details that improvements people want, and the nonprofits will make sure that we can handle all these requests, allow the community to make progress. We have proper documentation, proper automation. That's the to-do list is infinite, right? The nonprofits will help us a lot to deliver the vision.
Tell us more about this nonprofit. Is it the thing called Lean Focused Research Organization?
Yes, yes. Uh, it is funny because we in 2021, Convergence approached me and I wrote a proposal for this. I felt like, okay, this is going to be a good thing, even if it stays Microsoft research. It's going to be a good thing to have these non-profits for Lean, right? But then in the end of 2021, we had all these success stories about Lean with the Liquid Tensor Experiment project, MathLib showing up on Wired magazine, many talks. We had an article, people mentioning Lean in Nature News. We had all the success story. And the lab director said, okay, we are going to invest in Lean now. And I felt, okay, I mean, for people, for Sebastian, Gabriel, we had all these collaborators. It felt to me it's much better to have a long-term position in a big tech corporation than having a non-profit, right? Uh, but with the AI, the economic downturn, all this great, bright future was gone. And then I started talking with Convergence again, and they were super nice. They raised the money. They were great. I mean, yeah, I mean, super grateful for everybody that donated money. Was amazing. Super grateful for that.
Well, so sounds like this move from MSR to AWS was actually a pretty good thing for Lean. So I believe that we are all happy here in our end. About this non-profit organization. So is it a plan to hire more people? How's that going to be handled?
Yeah, there are a few people joining. I think until the end of the year, there will be 7 or 8 people
Oh, wow.
in the non-profits. Yeah, we're excited. Amazing people are joining. We're super excited to see them working there. But we want to stop at 10. We got funding for 5 years, 10 people, right? So we want to stop at 10.
Nice. And where do you see Lean going into the future? What are the immediate plans for developing it?
Well, we want a module system, right? This is a big deal. Our build system lake will have many improvements, right? We want to have something called reservoir. That's the way to explain is like crates.io for Lean. You want to have cloud build support. We want to have better proof automation. There are many performance improvements. The community, the to-do list is huge, right? But we want to have also better support for embedded languages, right? In Lean, that's one thing that we really care about, that people have been asking for a long time. For example, people want to be able to define their own embedded language and have auto-completion for this embedded language in Lean, right? That's one thing that will be coming. Sledgehammer for Lean is another thing. We really, Sebastian and I, working hard to find someone to work on that for Lean. Many cool things are going to happen. I mean, you ask me where I want to see Lean going. I would love to see Lean being applied for in software verification applications, right? I think it's important to have companies that benefit from Lean, use Lean, and can help to fund the projects in the future, right? Right now, it's all philanthropic donations that are maintaining the project, but this is great. I'm super grateful to have that, but long term, we need to have industrial customers, right? I mean, it's like Rust, right? Look, it's beautiful, right? They have so many applications. You have people in many different companies working on Rust. I mean, at AWS, Nico is there. It's great. I mean, I think I would be super happy if one day we're at the place where that Rust is today, right? I mean, but for improving, of course.
I'm sure. I'm sure we are headed towards that direction, especially with all the the application on usability, on making things easier for the user, and also writing our own plugins. Let's say inside Lean itself really helps to make embeddings towards our other language. So yeah, I can see that happening. Yeah, sounds like an exciting
Yeah,
future.
Another thing I forgot. The AI. Another thing that I would love to see is great AI being developed for Lean, right? Uh, it would be amazing, right, if we have AI synthesizing codes and proofs for us and proving the code that has been synthesized that has the properties we want. To see that happening would be awesome too. I mean, I hope I think the non-profits helps a lot with that. I mean, when Lean was perceived as a Microsoft project, other companies would be reluctant to use or claim they are using.
Right.
For example, sometimes you have silly things like Meta AI. They had a paper using Lean. They have a blog post, everything. They don't say Lean is developed by Microsoft, right? They go to these really indirect ways to say they're using Lean without saying Lean is from Microsoft. I understand, I fully understand. But now this problem doesn't exist anymore, right? I mean, therefore, who is a non-profit and is happy to support anybody that wants to use Lean to make progress. I think it's the same approach that Rust and other. I think Coq is using the same approach now. They have a Coq Foundation. I think that's the way to go for this kind of projects.
Yeah, that's really. Are all projects in MSR open source? Because this, I don't know, like it. I feel like it's weird, no? Like it pays for developers to work on this thing for a long time, and then I don't know, they don't have anything. I don't know how to properly express myself, but
what do you mean?
yeah, sorry. So are all projects at MSR open source?
There are. I mean, Z3 is open source, F-Star is open source. There are many. I mean, after 2011, Z3 was one of the first to become open source,
okay.
But we had many others since then. Many open source projects. Coca is open source. There are many now.
So my problem is that I have trouble visualizing how MSR can profit out of these open source projects. Does that make sense?
Yeah, this is a very general question, right? Like how do you develop open source? You know, how does open source plus big companies that want to make profits, how does that work? I think there's a much bigger question than Lean, right?
Yes. I mean, the first thing, I think Lean would have zero impact if it was not open source, right? None of these mathematicians would be using Lean if it was a closed source. The first thing, it would be zero impact. I think the leadership realizes research, you have to be transparent, right? I think it's super important. In many places, they would not even accept your paper if the code is not. You make claims about the code that nobody can see. It's really... Yes, really. I don't think it's good for science. I mean, and for many years, this is the goal, right? The goal is to move science forward, right? It has to be open source. I mean, I think this is non-negotiable. And also, all these projects are huge. I mean, you can't have a single company driving these projects. We have to take Rust as an example. Rust, there are many companies supporting LLVM, another one, right? Apple made a huge investment. And Apple is really tough with open source, right? But LLVM is open source, right? And now look, there's so many stakeholders. Look the impact the project has. Uh, I think it's essential. I'm a big believer. I would not work on no open source
I mean, I think the
projects.
lesson of the late '90s and the early 2000s, and I'm not. This is just my opinion. I cannot stress how much I don't actually have the data to back this up. But my impression is this idea of building software and selling software kind of petered out, right? By 2010, people weren't really selling software that much, right? You can still buy Windows, and there's plenty of software you can actually buy. But as a business model for billion-dollar companies, selling software is just not really there anymore, right? It's not what you want to be doing. So there's no real incentive. There's not as much incentive to keep your software closed source. What's much a bigger incentive is to say, hey, these foundational programming language and these foundational frameworks, these are open source. Anybody can use them. In fact, everybody should use them, right? Everybody should be using, these APIs for Chrome or for, everybody should be using them. And then, the sales pitch is we sell support for this infrastructure. We make it easy for you to do these things or to use these things. But the software itself, especially if it's something like a programming language or a framework or, a browser, that's not what you're selling. You're definitely not selling that. You're selling what you're using it for or how you're building it or how you're using it to deliver something.
True.
Yeah, I have to be honest. I'm not a businessman. I don't understand how to make money, and I don't care about making money. You should not ask me for this kind of advice.
You just want to be in your room doing your code and advancing lean.
Yes, exactly.
I'm afraid to say things about, hey, here's how AWS does business. Not only do I not really know, but also anything I say and that people take seriously is I don't know, there's no way I'm making informed communication. I think this is an interesting subject.
Well, thank you for the insight. I think they were really good. Well, with that, I pretty much finished all the things that I wanted to cover. I think we're in a pretty good shape. Is there anything that Cody would like to ask? Is there anything that Leo thought that we should have asked but we didn't?
No, it was great. I mean, I had a great time. I mean, I could spend the whole day talking to you guys. It was really fun.
All Pedro. Pedro has the magic touch for this.
It's not true.
Yes.
We came up with many of these questions together. We thought of this. Yeah, it was very nice to have you as co-host.
I had really low level questions about garbage collection and stuff like that. And Pedro is inclusiveness in mathematics, which is much more interesting to talk about.
Well, we still since Leo still want to talk, we could go into that. Why didn't you ask that question?
I asked it because every time I saw Leo work or do something, it was always he's obsessed with garbage collection. I remember I was like, why don't you just write it in OCaml? There's so much headache. He's like, you can't control the memory layout. You can't control the garbage collection. And then he was like, oh, and also I don't call malloc. Malloc is for snails, right? Malloc is just not fast enough. And I'm like, this is nuts. He wrote his own garbage collector, memory management. And then, Lean itself has this cleverness where they're trying to reclaim memory, right? If you're folding over something, it's great. But this attention to these low level details, especially memory management. I'm just fascinated, right? This is I never think about memory management. And I just want to know, what's your experience? Why are you so obsessed with this?
Well, the first thing, I don't remember saying these things, but it's not the first time. I mean, I think I'm getting old. People come to me saying, "Oh, you said that." I said, "Oh my gosh, I don't even remember."
That's the magic, right? You have impact on these people and you don't even know, right?
Yeah. Let me tell you one from Sunho. I mean, I recently, Sunho is at AWS too. We reconnected, right, recently. And he reminded me from one of these quotes, is saying about failure. Saying, can you fail? He asks me his quote. I don't remember saying that. When you were starting Lean, he asks me, "Oh, it's okay to fail." And I said, "No way, we cannot fail. There's no room for failure. I'm going to die. I prefer to die than fail. I'm going to do whatever it takes for this project to be successful. If you fail, you lose credibility. If you lose credibility, the next project is going to be harder to start. There's no room for failure." And I don't remember saying that. I said, wow, this is... Imagine you have these young students coming and asking for failure. It's not an option.
What's great? So, I mean, what's great is this is like, yeah, I mean, the tagline for, the biopic for Leo, played by Leonardo DiCaprio or something, is like, failure is not an option. That's going to be like the main speech of the movie, this thing that you said you don't remember.
But you have to ask next time you meet Sunho, you have to ask him to impersonate me. He does a really great job.
That's great. I should reconnect with him. Sunho, like Leo said several times, is an extremely impressive, like laser focused guy, and I think he's been doing really interesting things that I just don't, I haven't touched base with, which I seem to remember is a little bit more on the optimization side. So stuff that's cool, but I don't know as well.
Yes. Yeah, I'm trying to steal him to work with me.
Maybe he's too afraid to fail now.
No, I think I'm pretty sure Sunho is past that because he's had quite a bit of success. But like I said, his interests are very broad. So depending on what he cares about at the moment.
But yeah, you got me very curious, Leo. Could you comment more on this all this memory management thing and how much care sounds like you had to put into Lean?
Oh, this is what I mean. I'm assuming I had this speech. I was coming from SMT world, right? In SMT world, this is a thing, right? I mean, set solvers, SMT solvers, performance is really important. I remember quotes from Linus Torvalds saying, "If you don't know how to manage resources, you have no place programming," right? So, if you don't know how to manage your memory, you're not a real programmer, right? And there are all these attitudes, and in SMT, this is really important. So I think that's where it's coming from. Right now, it's gone, right? I use Lean to program, right? we have these optimizations for reusing memory, but it's automatic now, right? I mean, we're not allocating memory into allocating memory. We're not managing the memory ourselves anymore.
Okay, but what's kind of cool is what happens with typical large interactive theorem provers is everything. When you start building it, it's a bunch of logicians. Maybe they know how to program, but not necessarily, right? For Cock, for Isabel, I think the logicians, were first, and they do all this stuff. They don't care about performance. It's an interactive theorem prover, right? It's not, a SAT solver. You better be twiddling bits in memory because it really has to be fast. An interactive theorem prover, like the user is by far, the slowest piece of that puzzle. And then the system becomes successful. It becomes huge. And the libraries start taking seconds to load, and then minutes, and the tactics start taking minutes, and the conversion check starts taking minutes, and the universe hierarchy, like solving those universe hierarchy constraints, starts taking minutes. And now you have to go back in this huge code base, and you need to optimize it for speed, and that's really hard. So in some ways, I feel like this attitude of right out the gate, thinking very hard about performance. You don't always know it's going to be slow once things are huge, but already like you're saving yourself some potential problems.
Yeah. But for me at least, this came from the SMT world, right? I mean, the SMT people, I still in touch with them, and now at AWS we have lots and lots of SMT people there.
SAT, right? SAT people.
Yeah, but I feel SAT too, SAT and SMT, yeah, both. It's funny because I'm not into these things anymore, but people ask me questions, my opinion.
Yeah, it's too late.
Yeah. Yes.
That is great. Sounds like you are, no, it doesn't sound, you definitely are very respected there. Well, then, I think we covered everything. As I said, is there any other topics you guys would like to bring up?
Yeah, I don't. I mean, I'm happy to answer your questions. I mean, I don't like to ask myself questions, right?
Let's take those offline. But
Yeah.
well, so with that said, I'd like to finish by actually thank you both of you. Thank you, Cody, for making this happening. Thank you for being here. Thank you, Leo, for taking the time to talk with us. Let's definitely do another episode in the future. Let's still touch bases, but in particular, I would like also to personally thank you for being a Brazilian in this community and making stellar work. You are definitely an inspiration for all of us. Not many people know this, but we Brazilians, we have this, we call it stray dog syndrome, which means that we don't value our own work. We always look down at ourselves. And, being a Brazilian and seeing a person like Leo making this amazing kind of work is very inspiring for me. So thank you, Leo. That's the thing, you don't know how much you can impact other people too,
Yes. I love to be a stray dog.
Cachorro caramelo.
I feel like that explains so much. I wish I'd heard this years ago.
Yeah. Stray dog syndrome. Yeah. Well, with that, we complete this episode. Thank you so much, guys.
Thank you, Pedro.
Well, that's it for today's episode. I hope you guys enjoyed as much as I did. Leo is such a nice person. So I had too much fun talking to him. I hope you guys had fun as well. I definitely have plans to have him over again. I have plans to have everyone over again at some point. Anyways, if you have any questions, send them in our website, typetheoryforall.com. We also have an email, typetheoryforall@gmail. And make sure to follow us on Twitter at @TT4All. We also have that Discord that I talked in the beginning. If you have any suggestions and questions, Discord is by far the best means, but email and even on Twitter, I'm not super active on Twitter, but I always read everything that people send me there. So I think that's it. If you guys enjoyed this episode, make sure to send to a friend. That's all I ask. Send to a friend. That's it. See you guys in the next episode. Take care.